class.
Good evening, sir.
I am Akanchokse Kanjale Philip with registered number 20240708078, and I'll be your elective mathematics teacher for today. And we are going to look at an illustrative scenario explaining overgeneralization in trigonometry. And before we do that, at the end of this lesson, we should be able to explain overgeneralization. We should be able to give two examples of overgeneralization, and we should be able to tell why students do overgeneralize. Overgeneralization. Yes, Mr. Ezekiel.
A wrongful use of a concept.
Wrongful use of what? A concept. Very good. Yes, my good friend.
Yes.
So,
overgeneralization simply means that when students just feel that a particular rule applies to every situation.
Thank you very much. As you rightly put it, overgeneralization normally happens when learners or students apply mathematical rules or patterns or concepts too broadly beyond the situation where it is not valid. That is what is known as overgeneralization. So in mathematics, specifically in trigonometry, we'll be looking at overgeneralization on the trig identities. But before we move to the trig identities, where we'll be looking at overgeneralization, then let me take you through the trig ratio before we move to the trig identities. So looking at the cardboard here, you realize that we have a right angle triangle, and the longest part of it, that is line CB, is the hypotenuse, and AC is opposite, and then AB is what? Adjacent. So where the angle is always facing is the opposite, and where the angle is sitting on is what? The adjacent. So if you can remember, we talked of what? The three main trig ratio, and they are Simon.
Sine theta.
Sine theta.
And sine theta is equal to opposite over hypotenuse.
Sine theta is equal to opposite over what?
Hypotenuse.
Thank you very much. Yes.
We have cos theta.
Cos theta.
Which is equal to adjacent over hypotenuse.
Good. And the last one is?
The last one is tan theta.
Tan theta.
Yes, that gives us opposite over adjacent.
Thank you very much. So the other day, I gave you a particular name for this particular acronym, and I mentioned a particular name. Who can still remember? Yes, Simon.
Mnemonic.
Mnemonic. Very good. So this one is to enable you recollect sine. If they give you sine of an angle, it means opposite over what? Hypotenuse. This is what?
Cos.
That's cos.
Yes.
Which is what? Adjacent over what? Hypotenuse. So you realize that with the trig identities, if you have something like sine square theta plus cos square theta is equal to what? 1. Looking at this one, this is what? Our sine, our opposite, this adjacent, this what? Hypotenuse. So if you have a sine there, which we say is opposite over what? Hypotenuse. So let's assume that in this right angle triangle, this side is A, this side is O, and this side is what? H. So A, B, C. So in order to prove this particular identity, sine, which we said sine was opposite over what? Hypotenuse. Remember very well that sine square theta is the same thing as sine theta square. So, and cos square theta, you can also write it as what? Cos theta square. So in order to prove this, we have, let me clean the board then. Sine will now be opposite over what? Hypotenuse square. Plus what? Our cos is what?
Adjacent over hypotenuse.
Adjacent over hypotenuse square. So this one will be equal to what?
1.
1. Why?
Because sine square theta plus cos square theta is equals to 1.
Is equal to 1. So from this we have O square plus A square all over H square. And this will be equal to what? 1. But in Pythagoras theory, we learned that the longest part, if you square this, it should be equal to what?
Opposite.
The opposite square plus what? The adjacent what? Square. So it means that O square plus A square will be equal to what? H square. So we have H square all of what? H square, which is equal to what? 1. So because of this particular identity, you realize that students do overgeneralize on the identities. So whenever they see something like sine theta square plus tan square theta, they conclude that it's always equal to what? 1. Meanwhile, it is not always 1. It is not true. With this particular one, you can prove. Let's assume that theta is 45 degrees. So if theta is 45 degrees, let's substitute 45 degrees in place of what? Theta. So we have sine square 45 degrees plus cos square 45 degrees. So sine 45 will give you what? Root 2 or what? 2. But it's squaring.
Yes.
Plus cos, what will you get?
Cos 45 square. Root 2 over 2, say.
Root 2 over 2. Very good. So root 2 over 2. So this will give you what?
2 over 4.
2 over
4.
Over 4
Plus 2 over 4.
2 over 4. Which is equal to what?
1 over 2.
1 over 2
Plus 1 over 2.
1 over 2. Which is equal to what?
1.
1. Very good. So you realize that this particular identity is what? Valid. But students do overgeneralize. So whenever they see this trig ratio, the square of this trig ratios, if you are adding them, they conclude that is 1, which is not always what? The case. And another identity, so if you have something like cos square theta plus tan square theta, because of this identity, which is equal to 1, students overgeneralize that if they see something like this, it's also equal to what? 1, which is not what? True. Because if you substitute 45 here, or let's say 60, 90, or any angle here, then you have to prove. You are not going to get 1. For instance, let's use this one, where students do overgeneralize that since this one is equal to 1, this one too is equal to what? 1. To see whether we will actually get 1 or not. So now we will be looking at the reasons why students do overgeneralize. And one of the main reasons is that students normally they consider pattern recognition without understanding the actual concept. And another reason is that students memorize formulas instead of them understanding how to use those formulas or how comes those formulas to prove them. But they rather memorize them. And the last one, but not the least. Another reason why students do overgeneralize is desire for simplicity. They just want a simple way of doing it. So if they see a particular identity, because the other one is very simple for them, they just conclude that since this plus that is equals to 1, whenever they see sine square theta plus tan square theta, they conclude that it is equals to 1, which is not true. So I will entreat students to always try to understand the concept rather than what? Memorization. Thank you very much.